Okay, so let's talk about the Pythagorean identity, an intimidating sounding phrase, but it's actually not too bad, and it also relates to things that you already know. So here I have for us a little reference of the different quadrants of the unit circle and what the positive or negative sign is of the trig functions in each quadrant. And you could memorize these if you like memorizing a list, but if you remember that the sign is the y coordinate and the cosine is the x coordinate, that makes it pretty easy to figure out that the top half sign has to be positive, the bottom half sign will be negative, on the right half cosine will be positive, on the left half cosine will be negative, and then tangent is sine over cosine. So tangent is positive when the sine and cosine match, when they both have the same sign. And tangent will be negative when one of those is negative and one is positive. So you can kind of figure these out yourself, or you could memorize them either way. Okay, so we have the Pythagorean theorem that tells us that a squared plus b squared equals c squared for any right triangle. So I have a right triangle here, and I'll write a, b, and c. This refers to the lengths of these three sides. So the length of this side squared plus the length of this side squared equals the length of this side squared. But we also learned about how to draw these right triangles in the unit circle so that we can describe them based on the angle theta. So if I label this angle here, A is the same thing as the sine of theta, B is the same thing as the cosine of theta, and C is the hypotenuse, but because this is supposed to be the unit circle, this has a length of 1. So I'm going to take the Pythagorean theorem, and instead of A, I'm going to substitute in sine of theta. Instead of B, I'm going to substitute in cosine of theta. And then instead of C, I'm just going to write 1. So now I have a new statement where anytime this statement is true, this statement should also be true because they mean the same thing. And we know that this is always true for any right triangle. So that means that this statement is always going to be true for any angle. And it doesn't even need to be in quadrant 1. It could be in any of these other places where sine and cosine could be negative, because when we square it, that negative sign goes away anyway. So this identity works for any angle that we pick on the entire unit circle. And that's why we call it an identity. That just means something that is always true. So for any angle that we choose, this equation will be true, meaning we call that an identity. There are actually several trig identities that you might encounter, especially if you keep taking math classes through college, but this is really the one that we'll be focusing on in this course. But let's clean up this equation a little bit. So I've got a lot of parentheses here, and it turns out that raising the sine or cosine to an exponent is something that we want to do pretty often, especially squaring it. So there's just a convention, meaning it's just a way that people normally write it, to just write this as this, and to just put the exponent right on the word sine, basically. And this means the exact same thing. It means find the sine of theta and then square that value. So it's a little bit weird that the exponent kind of comes in the middle of the phrase. But because it's so commonly written, they wanted an easier, shorter way to write it. So this and this mean the exact same thing. And then 1 squared is just 1. So this is how you will normally see the Pythagorean identity written. There are a couple of other things that we could do though, because we just learned about these new reciprocal trig functions that are just what happens when we make fractions of the trig functions and flip them upside down. So let's do a little bit of rearranging of this equation. So one thing we could do is divide everything by cosine. So I have sine squared plus cosine squared equals 1. And I'm going to divide each of these terms by cosine squared. So I'm dividing everything in the equation by the same thing, so it should still be true. This, it should be easy to see. It's going to turn into 1. Sine squared over cosine squared. Well, tangent is sine over cosine. So this is going to be tangent squared plus 1 equals, and then 1 over cosine is the secant. So 1 over cosine squared is secant squared. So this might look like a completely different equation, but really it just comes from this same equation, but then I just divided each term by cosine squared and I got this one. And then I can do the same thing with this equation, but I'm going to divide everything by sine. So sine squared theta plus cosine squared theta equals 1. I'll divide each term by sine squared. This is going to be 1. Cosine over sine is cotangent, so this is cotangent squared. And 1 over sine is cosecant, so this is cosecant squared. Cool. So here are 3 different sort of results, or 3 different ways of writing the Pythagorean identity. If you want, you can just remember this one, and then as you go, you can kind of refigure out some of these ones just by dividing everything by the same quantity. Okay, so let's see how we would use this information. So I have a couple problems written here. The first one says the tangent of theta equals negative 0.75, and the terminal side of theta is in quadrant 4. So now we're going to try and fill in what all of these different trig functions are based on this one that's given and based on the quadrant. So I can check my little chart here. It's in quadrant 4. That means that the tangent should be negative, and in fact we know it's negative 0.75. The sine should be negative, and the cosine should be positive. And then sine and cosecant. Cosecant is 1 over sine. So they will always go together. They will always either both be positive or both be negative. Same for secant, same for cotangent. All of these values kind of go together, the signs will always match across the rows here. Okay, so I know one of these numbers, and I want to use that to figure out the rest of them. So here's my choice of identities. I know what tangent is, so I'm going to choose this one. So negative 0.75 squared plus 1 equals secant squared of theta. Now I'm going to figure out what this actually is. You could do it with a scientific calculator, with a graphing calculator. It's not too bad. You could probably do it by hand also since it's a fraction, but I'll just do it like this. Negative 0.75 squared plus 1 equals this number. Or I think this has a fraction to decimal button or decimal to fraction button that will give it to me as a fraction. I don't remember which one it is though, so it's fine. Equals secant squared theta. So now to find the secant, I can just take the square root. Okay. And then I get that it is 1.25. Okay, so 1.25. Anytime you take the square root like this, it won't necessarily tell you what the Anytime you take the square root like this, it won't necessarily tell you what the positive or negative sign should be, because we're taking the square root of something squared that usually gives us a plus or minus. But we already figured out what the signs should be using the quadrants and the unit circle. Okay, so I know that this is 1.25. I also know, so now I've got two values filled in. So I'm making good progress. Let's keep going. I've got some easy stuff here now. So I know that secant is 1 over cosine. Technically, it's not really correct to write these without theta, but depending on what you're doing, it doesn't matter that much. So I know that this has to be true. So 1.25 is 1 over cosine. So then to solve for cosine, I can just basically flip the fractions on both sides, and I'm going to get 0.8. So there's more than one way to solve this equation, but when you have 1 over, one easy way is to just raise both sides to the -1, and I'll get 0.8 equals cosine of theta. So cosine is 0.8. Okay. We can keep going. I know that cotangent is 1 over tangent. So I can do 1 over negative 0.75. And I get negative 1.33 repeating. Now I just have the sine and the cosecant. I now know cosine, so if I wanted to, I could use sine squared plus cosine squared equals 1. Or I can use the fact that sine over cosine equals tangent. So either one of those two things would work. So sine of theta over 0.8 equals negative 0.75. So to solve for sine, they will multiply these two things. And I get sine of theta equals negative 0.6. And cosecant is 1 over sine. So 1 over negative 0.6 is negative 1.6 repeating. There we go. So now I figured out all 5 of the other trig values just based on that one value. Generally speaking, you'll need to use one of these equations at least once, and then from there you can either use more of these, or what's a little bit easier is you can just use the ratios and relationships of the reciprocal trig functions, which are on that page on Canvas in the table. Okay, let's do another one. So I have cosecant equals 2, and theta is in quadrant 2. So cosecant equals positive 2. Now, I know that the sign always has to match across the rows. Quadrant 2, cosine should be negative and tangent should be negative, which means that these ones are also negative. Okay? Now I'm ready to try to find some of these other values. I could use this formula, but to be honest, I find it kind of confusing. I'm a lot more familiar with the sine and cosine one. So I'm first going to use the relationship that cosecant is 1 over cosine. Or sorry, 1 over sine. So I know 2 equals 1 over sine of theta. That means that the sine of theta is going to be 1/2. There we go. So I find that a little bit easier to use. And then I can do this Pythagorean identity, sine squared plus cosine squared equals 1. So I have 1/2 for sine. Cosine, I don't know yet. And this equals 1. So 1/2 squared is 1/4. 1/4 plus cosine squared equals 1. I will subtract the 1/4 from both sides. And then I'll find that cosine squared of theta equals 3 over 4. I'll square root both sides to try to find out what the cosine is. And I will get cosine of theta equals, technically there's a plus or minus here, but we already figured out that it's going to be negative. And look, it's our old friend, the square root of 3 over, and then the square root of 4 is 2. So this should make sense that a sine of 1/2 goes with a cosine of square root of 3 over 2. We've seen that a bunch of times now. And here it is in a different context. Okay? Now tangent is sine over cosine. So tangent would be 1/2 over negative square root 3 over 2, which ends up just being negative 1 over square root of 3, or if you wanted to write it in rationalize the denominator, you could write it as a square root of 3 over 3. But I'll just write it like this. Here we go. And then these ones are easy. We just got to flip the fractions. So I'll flip this fraction, and I get negative 2 over square root 3. And I'll flip this fraction, and I just get square root of 3. There we go. So you can use a calculator and solve these with decimal numbers. You can solve them with fractions. You can also try to keep everything exact by solving the equations like this, where we found a fraction and took the square root, and then we kept that square root as part of our answer. All right, I know this probably was a lot. I will try to make sure I give you guys the time and opportunity to ask questions if you need to, and get a little more practice with these. Hope everybody's having a good day, and I will talk to you again soon. Bye.